The GitHub Actions support makes it easy to automate your software workflows. You can now build, test and deploy your code directly from GitHub, making GitHub a perfect continuous improvement and continuous development platform. The GitHub Actions are not something new to the table, these features being already available amongst the big players in the industry like GitLab, Azure Devops and so on. So why is this such a big deal? Well, unlike its alternatives, GitHub is free and offers the possibility to run these actions on GitHub hosted runners, meaning you don't have to worry about investing in powerful machines to do what GitHub is doing, nor pay for the service like with Azure Devops. GitHub offers a suite of standard actions for different kinds of automations that might be beneficial for developers, such as C++ with Make, deploy a .NET Core app to Azure Web App, and so forth and so on. But what if you want to automate the build of your MSI as well? Here is where Advanced Installer comes into play, and Advanced Installer now offers its own GitHub action that you can use. If you are a skilled developer, chances are you know how to use automations and how to leverage the Advanced Installer GitHub Action support by simply scanning our README file without any handholding. Therefore, this tutorial is meant for beginners. We will go through a step-by-step guide to help you build your MSI with GitHub Actions. The first thing we need is an Advanced Installer project. This project will contain the definition of your package in terms of files, folders, registry, custom actions, and so on. We have different tutorials on our user guide on how to create a simple installation, professional installation, enterprise, and so forth and so on. Don't worry, you don't have to do this every time. If you want to adjust certain things inside your MSI with each build, you can use our command line support or PowerShell support that Advanced Installer offers in terms of editing your projects. We will go through these details a bit further as we will dive in the creation of the GitHub automation YML file. For this example, we created a simple Advanced Installer project. This project only contains a few registry values and two files which are going to be installed in the default directory defined under Install Parameters page. The files are stored inside the project as a relative path by default, so you don't have to worry about hard-coded paths when you upload the project on GitHub. As a best practice, it's good to save the Advanced Installer project near your file or folder structure. In this example, the Advanced Installer project is saved near the source files which it contains. Once the project is configured, upload it to your repository, and at the end it should look something like this. Now that the Advanced Installer project is uploaded, it's time to create the GitHub action that will perform the build. To do this, navigate to the repository and click on Actions. Next, create a new workflow. GitHub will offer you a set of standard actions that you can choose from as previously mentioned, but we will choose to set up a workflow yourself. This is the step where the .github/workflows directory structure is created. Inside this directory, all the workflows, which are just YML files, are stored. In our case, we named our YML file sample app. Inside the editor, we've used the following code. Let's quickly explain what is actually happening inside this YML. The name field represents the name of your workflow. You can configure it as desired. The YML file can define a set of jobs, and each job can have multiple steps or actions. The YML file is configured to run on Windows latest. As previously mentioned, this is where you configure on which type of host you wish to run your actions. A full list of GitHub hosted runners can be found in the blog post, so please check that out. The first action is to check the repository code just to be sure that no issues are present. The checkout at v2 is a standard GitHub action. The second action is to build the AIP project, and we reference the Advanced Installer GitHub action that is now available on our repository. This action will integrate Advanced Installer tool in the GitHub workflow. It has the following capabilities: to deploy an Advanced Installer on the GitHub runner and build an Advanced Installer project. The action supports input parameters as seen in the example above. The input parameters are of two categories. Tool deploy parameters, where their names use the format advanced installer minus something, and AIP project parameters, where the names use the format AIP minus something. We configured our action to use Advanced Installer 19.1 version, added our license, defined the path where the AIP project is located in GitHub, and in our case it's on the master repository. If you have it in a subfolder, make sure to correctly configure this into the YML file. Define the name of the resulted MSI, in our case it's sample.msi, and the output directory of the MSI. We also set an additional property in the MSI and increase the product version of it. The third action builds the artifact and uploads it to the repository. It is not recommended to put the license in plain sight inside the YML file. To hide the license, navigate to the repository and click Settings. Next, click on Secrets and create a new secret where you paste your Advanced Installer key. You can consider secrets something like variables. In our case, the name of the secret is Advanced Installer /license/key, as seen in the YML file. Now that the action is defined, click on Start Commit and your workflow will be saved. The last step is to actually run the GitHub action. And if we navigate back to Actions, the new configure workflow will be present there. All we have to do is click on Run Workflow and the build should be started. After a while, the actions should start and perform the necessary steps that are defined in the YML file, and once it's completed, you should see something like this. This is the artifact, and if we click on it, you should see the resulted MSI file. In this case, it's a setup.zip file. This contains the actual compiled MSI. Then you can download it, extract it, and open up the MSI with Advanced Installer. You should see all the changes that we previously placed in the YML file, like the product version or the additional property. And that's pretty much it. The tutorial is intended for the build of an MSI using the AIP project, but Advanced Installer supports multiple types of actions, like the use of automation with PowerShell as shown in our GitHub example, or even build a Visual Studio project. For more examples, check out our Playground repository. The link is in the description. We would love to hear your feedback. Tell us how to improve this action at support@advancedinstaller.com or open up a GitHub issue.